Hi good people, this is Kawes. Let's talk about physical chemistry. In this video, I will teach you what physical chemistry is, its techniques, the theories, as well as its applications. So, let's get started. Physical chemistry is a branch of chemistry which deals with the physical structure of chemical compounds, the way they react with other matter, and the bonds that hold their atoms together. Physical chemistry focuses on understanding the physical properties of atoms, the way chemical reactions work, and what these properties reveal. It involves analyzing materials, developing methods to test and characterize the properties of materials, developing theories about these properties, and discovering the potential use of the material. We will also look at different various topics such as laboratory techniques, matter, chemical bonding, atoms, elements, as well as compounds. We'll also look at the mole concept, stoichiometry, acids, bases, and salts, electrochemistry, chemical energetics. We'll also look at reaction kinetics, and our final subtopic will be equilibrium. In this video, we'll cover the scope of laboratory techniques, and under this topic, we'll discuss measuring instruments as well as separation methods. By the end of this video, you should be able to identify suitable apparatus used in measurement of base quantities such as temperature, mass, distance, time, and volume, and to use measuring apparatus correctly and properly. Now, let's check out the apparatus used in a laboratory. We have the most common apparatus used in a lab, the mass balance. This instrument is used to measure mass. We also have got a thermometer, which can be either digital or alcohol, and this instrument is used to measure temperature, which is usually in Celsius. There is also a volumetric flask, which is used to prepare solutions to an accurate volume. We also have got a beaker, and this one is used for holding, mixing, and usually heating liquids. There is also a Bunsen burner, and this one is usually the heat source in the laboratory. A ring stand, which is used to hold or clamp laboratory glassware. Burette, this one is commonly used in titrations, used for dispensing an accurate volume of a liquid. Test tube rack, which is used to hold several test tubes. We have a pipette bulb. This one mostly is for drawing liquids. Graduated cylinder for measuring precise volume of a liquid. There is also a funnel which can be used in the process of filtration or for transferring liquids into containers. A water bottle, which is mostly used to rinse pieces of glassware in a lab. A watch glass, which is used to hold solids during weighing or for covering a beaker. For picking, we usually use forceps. A volumetric pipette, used to measure small amounts of liquids very accurately. We also have steering rods, crucibles, test tubes, as well as mortar and pestle, which is mainly used to crush and grind material. Now, let's move on to the next section where I'll teach you how to correctly use these apparatus, especially when measuring essential base quantities such as volume, mass, and temperature. Let's start off by understanding how to use a cylinder correctly. To measure volume of a liquid, place the graduated cylinder in a flat surface and match the height of the liquid column directly with the level of your eye. Read the volume value at the bottom of the meniscus. This is shown in the diagram here, and if you read correctly, you should get 67 centimeters. Let's now move on to proper mass measurement using a mass balance. Before using a balance, it's important to take some important steps. This will help ensure you get the most accurate and precise measurement. Be sure you understand how to use a balance before taking mass measurements. The balance should be clean and free of debris, and it should be also on a level surface. Let's now move on to proper use of a thermometer. To obtain accurate results, place the end of the thermometer with the reservoir of the liquid in the testing medium. For example, if you are testing the temperature of ice water, as shown in this diagram, place the reservoir in the water below the ice but not touching the bottom of the flask. Then, interpret the readings correctly. That's all for instrumentation. Our final subtopic under laboratory techniques is separation methods. And by the end of this topic, you should be able to identify different methods of separating mixtures, as well as suggest suitable separation techniques given the nature of the mixture. The separation methods which will be under discussion include filtration, distillation, crystallization, evaporation, as well as thin layer chromatography. Let's now look at filtration process. This is an operation that separates solid matter and fluid from a mixture with a filter medium which only allows fluid to pass through. Filtration is used to separate particles and fluid in a suspension, where the fluid can be a liquid or a supercritical fluid. The process is shown in the diagram here. The process of filtration is further explained with the aid of an animated video here. The next separation method is distillation. This is a procedure by which two liquids with different boiling points can be separated. It can be used effectively to separate liquids that have at least 50 degrees difference in their boiling points. As the liquid being distilled is heated, the vapors that form will be richest in the component of the mixture that boils at the lowest temperature. As distillation progresses, the concentration of the lowest boiling component will steadily decrease. Eventually, the temperature within the apparatus will begin to change. A pure compound is no longer being distilled. The temperature will continue to increase until the boiling point of the next lowest boiling compound is approached. This is further explained with the aid of a diagram here. Here is the video for distillation process. Now let's move on to the process of evaporation. This is the conversion of a liquid to its vapor below the boiling temperature of the liquid. It is a process whereby atoms or molecules in a liquid state gain sufficient energy to enter the gaseous state. An example of evaporation is water turning into steam. Evaporation takes place at the surface of a liquid where molecules with the highest kinetic energy are able to escape. When this happens, the average kinetic energy of the liquid is lowered and its temperature decreases. The process of evaporation is illustrated here in this animated video. The next separation technique is crystallization. This is a process by which a solid forms where the atoms or molecules are highly organized into a structure known as a crystal. It's the process of obtaining crystals of a soluble substance from its hot solution, and it is used to obtain pure substances from impure compounds. Crystallization occurs in two major steps. The first is nucleation, the appearance of a crystalline phase from either a supercooled liquid or supersaturated solvent. The second step is known as crystal growth, which is the increase in the size of particles and leads to a crystal state. The process is shown in the diagram here. The process of crystallization is shown in the animation video here, whereby paracetamol is being extracted from acetaminophen through the crystallization process. Now, let's move on to the last separation technique in this topic, that is thin layer chromatography. This is a technique which is used to separate non-volatile mixtures, and it is performed on a sheet of glass, plastic or aluminum foil, which is coated with a thin layer of adsorbent material such as silica gel or aluminum oxide, also known as alumina. When the sample has been applied on the plate, a solvent known as a mobile phase is drawn up the plate via capillary action. Different analytes ascend the TLC plate at different rates, and hence separation is achieved. Thin layer chromatography can be used to identify compounds present in a given mixture as well as determine the substance purity. The chromatograph picture is shown here, which further explains the process. Specific examples of thin layer chromatography applications include analyzing ceramides and fatty acids, detection of pesticides or insecticides in food and water, analyzing decomposition of fibers in forensics, assaying in radiochemical purity of radiopharmaceuticals, or identification of medicinal plants and their constituents. This marks the end of this video. In the next video, the topic under discussion will be matter. Thanks for watching. Stay tuned for more upcoming videos and don't forget to click the subscribe button below.